Welcome to True Projects. In this video, we are going to explain about the project entitled as Quantum Resistant Blockchain Protocols for Secure Transactions. So before getting into the video, let me give you the brief description about the project. The project focused on designing and implementing blockchain systems that remains secure against attacks from quantum computers. It integrates post-quantum cryptographic algorithm to replace vulnerable classical encryption methods like RSA and ECC. The goal is to ensure long term data integrity, authentication, and transaction security in decentralized networks. This approach future proofs blockchain infrastructure against emerging quantum threats. Coming to the abstract describing a quantum resistant blockchain protocol developed to secure digital transactions from quantum computing threats. It explains that traditional systems using RSA and elliptical curve cryptography, which are vulnerable to quantum attacks. To overcome this limitation, the system integrates crystals dilithium within a hybrid framework for secure digital signature verification. Smart contracts are deployed on Ethereum to manage transactions in a decentralized and tamper proof manner. Additionally, transaction data is encrypted using the advanced encryption standards to ensure confidentiality. The abstract concludes by noticing that although the proposed system has slightly higher latents, it significantly enhances the security. Coming to the existing system, this existing system explains that the current blockchain system relies on classical cryptographic algorithms like RSA and ECC for digital signature generation and verification. While these algorithms are efficient and widely adopted, they are vulnerable to quantum computing attacks that can break cryptographic keys. It also highlights that transaction data is stored in plain text format on the blockchain, meaning anyone with the contract address can view transaction details. Although the existing system ensures decentralization and immutability, it lacks quantum resistant and strong data confidentiality. Coming to the proposed system introduces a hybrid quantum resistant blockchain protocol that integrates crystals dilithium for secure digital signatures. It describes the workflow including transaction creation, digital signal generation, broadcasting, validation, block formation, block signing, block validation, and consigns finalization. Smart contracts are deployed on Ethereum to handle user registration and transaction processing. The hybrid approach allows both traditional and post quantum signatures to work together, ensuring backward compatibility. The system also compares performance in terms of latence and throughput, stating that while RSC or ECC are faster, Crystal's dilithium provides stronger long term security. Coming to the extension explains that the original proposal focused on a securing digital signatures and did not protest transaction data stored in plain format. To address this limitation, the system encrypts complete transaction data using AES before storing it on the blockchain. This ensures that even if someone accesses the contract address, they cannot read the transaction details in plain text, thereby improving data confidentiality along with quantum resistant verification. And as an extension, we have used Ganache with MetaMask. Ganache is a local Ethereum blockchain environment for deploying and testing smart contracts. Ganache provides pre-funded accounts, transaction logs, block details, and gas usage information. It helps stimulate real blockchain behavior into a secure testing environment before deploying to a live network. Coming to MetaMask, MetaMask is a browser based Ethereum wallet used to interact with the decentralized application. It enables secure login transaction sign in, certificate handling, and verification. MetaMask also displays wallet balance, confirmations, and gas fees, ensuring transparency and easy to use. Coming to the modules, first we have new user sign up module. This module allows new users to register in the system. User details are stored securely on the blockchain using smart contracts. Once registered, the user becomes part of decentralized network and can perform transactions. Next, user login. The user login module authenticates registered users after successful login. Users can access system features such as creating or verifying transactions. Authentication ensures only valid users interact with the system. Next, sender create transaction. In this module, the sender selects the receiver, enters transaction details such as amount and date, and generates a digital signature using Crystal's dilithium. The transaction details is encrypted using AES and then broadcast to the blockchain for storage and validation. Next, receivers verify transaction. This module allows the receiver to retrieve transaction details from the blockchain and verify the digital signature using the sender's public key. The system checks whether the generated signature matches the stored signature to ensure authenticity and integrity. Next, latency graph. The latency graph module compares the performance of RSA and Crystal's dilithium algorithm. It plots the number of transactions against latence, showing that RSA is faster but less secure, while Crystal's dilithium has slightly higher latency but provides stronger quantum resistant security. Coming to the requirements, hardware requirements consisting of operating systems Windows only, processor i5 and above, RAM 8 GB and above, ROM 25 GB and above. Software requirements consisting of Python 3.7.2, Node.js 18.17.1, Visual Studio Community version, Ganache, MetaMask as a Chrome extension. Coming to the backend languages, we need Python, JavaScript, and Solidity. Framework which we have used is Flask. Front-end languages are HTML, CSS, JavaScript, and Bootstrap 4. To execute the project, first we need to open the project code folder which contains the project source code files. Static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. Templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Run.bat file. Instead of executing the project to the command line interface, we have created the run.bat file. Coming to the execution of the project, first, we need to open Ganache. Then we need to open the workspace which we have created for quantum resistant blockchain. The Ganache has been successfully hosted. In the server, we have accounts, blocks, transactions, contracts, events, and logs. When you click on accounts, here you will have the current blocks, gas price, gas limit, network ID, RPC server, and mining status. These are the addresses, and this is the balance of the Ethereum. This is the transaction count, and this is the index. Ganache is a personal Ethereum blockchain used for development and testing of smart contracts. It is a part of Truffle Suite ecosystem. Blocks. A block is a container that stores the transaction data, stores multiple transactions, have a block number, contains a timestamp, contains a hash, which means a unique ID, linked to previous block. Blocks are mined instantly. Every time you make a transaction, Ganache creates a new block. Coming to the transaction in Ganache, a transaction is an action performed on the blockchain. Each transaction contains sender address, receiver's address, amount of Ethereum, gas limit, gas price, transaction hash, and statuses, which means it is successful or failed. Coming to the contracts, now just minimize this Ganache and copy the path of the code folder from the address bar of the file explorer. Then open command prompt. Use the command cd followed by a space and then paste the copied path in the command prompt. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py in the command prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address with the port number of 5000. Copy the local link provided by the framework and paste it in any web browser. I prefer Chrome. so that the home page of the project should now be displayed in the browser. This is a front-end build using the Flask framework. In this page, we have home button, user login button, and new user sign up button. Now, let us click on new user sign up button. Let us click on new user sign up button so that the create account form will be opened where you need to enter the details and create an account for user authentication. Now let us create an account by using the username, password, contact number, mail ID, and a full address. Click on create an account so that the account has been successfully created, which means it has been added to the blockchain network. So whenever we are going to give the details are also stored in hash address, which means a unique ID. And here we have the gas used percentage and status is success. Now close the window and again let us enter another user. Now click on create an account so that again the given details are stored in blockchain with the help of transaction hash, block numbers, and gas used and status. Now close the window and click on user login. Now let us log in to the user by giving the username and password. Username and password. Then click on sign in so that if the given details are correct, then it will directly log into the page. And in this page, we have sender, create transaction, receiver, verify transaction, latency graph, and logout button. So first click on sender, create transaction. As we have created two users, now let us select the receiver first. As I have logged in as Vandana, now I'm just selecting as Carmel. I'm just entering the transaction amount and then click on generate and send the transaction so that the transaction has been successfully completed. The receiver name is given here and the amount is also given here. The signature which we have made is given in dilithium signature format, like with some kind of numbers. And here the details are stored in blockchain with the help of hash address, block numbers, gas usage, and status. Now close this transaction and log out. So as we have sent it from Vandana to Carmel, now let us log in as Carmel and check whether we received the amount or not. Click on sign in. Now click on receiver verify transactions so that the sender is given here. Sender details like sender information, receiver information, the amount which we have transferred, the date and time, and security and verification details are given below. Okay, then click on close. Click on latency graph so that the graphical representation will be opened. X-axis consists of algorithm names and Y-axis contains latency. Click on logout. So finally, quantum resistant blockchain protocols are essential to protect digital transactions from future quantum computing threats. Once after the transactions has been completed, let us open the Ganache. So here earlier there are 15 transaction count. Now this has been increased, but the balance of the Ethereum remains the same. To know whether the Ethereum has been used, let us check by logging into the MetaMask. Login. Here you can see the Ethereum value like 99.989 Ethereum. So in Ganache we have 99.99 and in MetaMask it's clearly showing that 99.989. So finally, quantum resistant blockchain protocols are essential to protect digital transactions from future quantum computing threats. By integrating post-quantum cryptographic algorithms, blockchain system can maintain data integrity, authentication, and security even in a post-quantum era. Although challenges like increased computational overhead exist, proactive adoption ensures long-term trust, resilience, and secure decentralized transactions. This is all about your project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.